Hey 6B, let's review our practice tests. So let's take a look at the first one. If we look at the data given about the distance of frogs' leaps in inches, we see that we have a line plot. On this line plot, what we can do is we can find out all of this information relatively easily. Our minimum is clear. Our minimum is our smallest value. So our smallest value would be here. The smallest distance is 11. Our maximum is up here. It's 18 because it's the greatest place where there's an X. And so I'll put 18 here. Remember that our range is our maximum minus our minimum, which gives us here a range of 7. Our mode is the number that appears most. And when we see that the data point 12 appears 5 times and the data point 14 appears 5 times, we realize that we have 2 modes, so it's bimodal, and so our modes will be listed as 12 and 14. Our median is listed as the center number, so this is where you'd want to take some hatch marks and find out what the middle value is. So what I mean by hatch marks are these little red lines that I've done on either side until I got to the center or the center 2 values. So if I were to have all the numbers written out, 11, 12, 12, 12, 12, 12, 30, 30, 30, so forth and so on, I'd be left with 2 14s in the center. That's really easy to take the average of. The average of 14 and 14 is 14. So the median is the center number, or the average of the center 2 numbers. Sometimes we say the center of the center 2 numbers. And the mean we're going to find with our calculator. Here's a quick way to calculate. We're going to add, we know that there's 22 x's, so that means there's 22 data points. We're going to add 11 plus, since we've got 5 values of 12, 5 times 12, plus 3 times 13, plus 5 times 14, plus 2 times 15, plus 3 times 16, plus 17, and plus 2 times 18. And I'm going to put my multiplication symbols in there so we're not confused. So I'm multiplying these 2 numbers because that's how many of each data point I have with those values. After that, I'm going to divide this large number, so let me put large brackets around it, by 22. Because there's 22 data values. And when we've done all of that, we end up with a mean of 14. And that's from calculating this, the sum of all the data points and then dividing it by the number of data points. Let's look at number 2. Our example before had a line plot. We're going to do the same thing. Let's get started. So taking my time, this is what I got from my line plot, and now I'm going to do the same exact thing we did last time. We're going to look for the major landmarks. Maximum, we can clearly see, is 23. The minimum would be 6. The modes, well, there are several modes. The modes are going to be 10, 12, and 17 because those are the values that appear the most. Let's put 10 first. 12 and 17, and finally the range is going to be the difference between our maximum and our minimum as we had before, and that's going to be 17. Here we're going to put together a stem and leaf plot, which should be really straightforward because many of you are really good at this. One thing I'd like to say is this is not a double stem and leaf plot where it doesn't say double stem and leaf plot, it's just a straightforward stem and leaf plot. So that means we only have one digit for each of the tens place. What does that mean? I look at my data here and I see that we're going 20s, we've got 30s, we've got 40s, we've got 50s, we've got 60s. So I'm going to put a 2, 3, 4, 5, and 6. I'm not going to do, I remember we had an example where we did 2, 2, 3, 3, 4, 4. That's a double stem and leaf plot. That's not what we're doing here. So I'm going to fill this out. I just looked across and found all my 20s, and I made sure and put them in order 5, 7, 9, 9 for each of the 4 ones places represented for the 20 value here, and I'm going to finish it up here. And here's my stem and leaf plot. Pretty simple, right? All right, let's find the maximum. The maximum would be the number that appears the lowest and further out, so that's 61. My minimum would be the highest number, 25, the number located highest on my chart, 25. My maximum is my greatest number, and my minimum is my smallest number. My mode, as I look carefully, I see 4 appears a lot of times next to the 4 tens in terms of the stem, so that's going to be 44. And my range will be the difference between 61 and 25, which is 36. We've got recorded times for a lacrosse team running a mile, and these times are in minutes, and they're here. We are to find the median and the mean. To find the median, we need to list things from smallest to largest. To find the mean, we're going to add up all the data and divide by the number of data values. All right, so they're arranged from least to greatest, and now I'm going to use my hatch marks to find myself in the center of my data. And when I do that, I have 2 points that are there, 7.6 and 7.6, which is totally easy to find the average of or the center of, and that answer is 7.6. Excuse me. So that's 7.6 for my median. Next, let's find the average or the mean by adding all of these up and dividing by the number of numbers. So when I add all these numbers up, I get 90, and when I divide it by 12, I get 7.5. So that's what we get here, 7.5. And so now this question is interesting. It says, which landmark, median or mean, do you think gives a better representation of the times of the lacrosse players' miles? And so you can choose one, median or mean, and I'm going to leave this open for you. And then explain your thinking. Explain why you think one is better than the other. Sometimes one of the explanations, and you can actually give a compelling reason for either in this case. So I'm not going to make the case to say one answer is more correct than the other. But here's some things to think about. Look at your data. See if there's any outliers, if there's any numbers that are abnormally high or abnormally low. That influences the mean. Does that influence the median? How does that work? Our median and our mean are pretty close in this case. What does that mean, and how does that affect your answer? So this is more of an open-ended question that I'm going to leave for you. The second part of this open-ended question is one that a lot of you asked about in class. Is this a representative sample of the average person's time for running a mile? Why or why not? And one of the answers that I thought was pretty compelling is that no, this isn't, given the fact that we're dealing with lacrosse players who are most likely athletes. Let's take a look at the next problem. Whenever we encounter a line graph, the first thing you want to do is really just get a lay of the land. Look at the information that's given. Here, you guys can see it a little bit more clearly on mine because it's in color than yours. But if you notice, the lines with circles refer to a high temperature. The lines with diamonds or boxes refer to the low temperature. We're talking about the temperature of Seattle in March. We see that there are dates across the horizontal axis and temperatures along the vertical axis. The dates are telling us what day each particular temperature or high or low was met. So we see that there's a high or low each day because each day has a high and low temperature. Now that we've done that, it's time to go and talk about the question. Study the double line graph at the right. It shows high and low temperatures for 2 weeks in March in Seattle. A, between which 2 days, so we're talking about between which 2 days here, did the high temperature increase the most? So what we're looking at is the high temperature only. I'm going to use a highlighter to see if we can highlight that. So where do you see the steepest increase? For me, it's either this section here or this section here. And when I look really closely, this jumps from about 44 to about 54. Whereas here, this jumps from about 46, 48 maybe, all the way up to 60, 61. To me, the greatest jump is here. So this is going to be my selection. Let me get rid of that. This will be my selection right here. And so the 2 dates that are being, that this jump corresponds to would be March 7th and March 8th. The next one, by how much did the low temperature decrease between the 4th and the 7th? So they're asking me to go to the 4th and the 7th, and what I'm looking at now, I'm going to highlight this in orange, is the low temperature between the 4th and the 7th. So here is this drop. How much did it decrease? Well, what we're going to do is we're going to find the maximum temperature, which is here, and this minimum temperature, and we're going to find the difference. All right, so for me it was 44 minus 30 degrees, which gives us a drop in temperature of 14 degrees. I'm going to erase, not my graph, just the extra stuff that I wrote on it, so we can get started talking about this next one. What date had the greatest temperature change between low and high? So to determine that, we look for the greatest distance between the two line graphs. And for me, it seems like it's happening here. On this day, it was pretty warm, and then the temperature dropped down all the way back down to the low 30s. So I see this day seems to have that greatest temperature difference, and that's the 8th of March. And then what observations, the date with the greatest temperature change? Yep. What observations can you make about March temperatures in Seattle based on this graph? So what would you say? You notice, does it get too warm? The warmest it gets is 60 degrees. This is March, the beginning of spring. And does it stay below freezing? Freezing is 32 degrees, so we're looking around here. So you've got some concepts that you can use to answer the next question. So when you look at a graph and you're asked an open-ended question, you want to make sure and think through what the graph means and give a sentence or two about what you see. All right, I'm going to leave that one to you guys. Let's take a look at this next one. So this next opportunity gives us a chance to construct our own bar graph, which is pretty cool. We remember that bar graphs show frequency or amounts in bars. What we also need to remember is that the first column generally refers to our horizontal axis, and then the second column usually refers to our vertical or up and down axis. So I'm going to label them accordingly. So I'm going to put my class year down here and my Innisbrook sales along the side. Next thing I need to do is figure out a way to make sure I can incorporate up to $8,000. When I look here, I'm thinking 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. It looks like I can almost, but not quite, give about 1,000 for each space, for each two spaces. So I'm going to do that, and I might have to tack on a little extra at the top. So here's what we have as our bar graph. Notice that we have the finances along one side and the year along the other, and we can visually see just how much more Innisbrook sales were in for the class of 2016 than the class of 2014. This question, if you wanted to show the results of different yearly fundraiser in the same graph, what could you do? This is in reference to what we remembered when we had side-by-side bar graphs. We might have something like, let me use a color here, we might have the bake sale. And the bake sale for 2014, for the class of 2014 may have raised $2,000. I'm making up this data, but I'm showing how you could represent on the same graph a different bit of information. What am I doing? What kind of bars am I making? Notice that I'm making bars of different colors. So these bars of different colors can be right at the side of the bars for the Innisbrook sales, which indicates to me just what happened in terms of what happened that year with two different sales. So the answer here is, what kind of graph would that be? It would be a side-by-side bar graph. Okay, so let's look at number 7. So again, this chart shows something interesting, so we want to make sure and understand what we're looking at. The chart is showing the number of tadpoles in a pond, and according to the graph, by how much did the tadpole population change from 1994, so we're looking at this date, to 1997. So when we look at change, we want to look at the difference between the values. So the value here is about 400, and the value here looks like 600, maybe 620, it looks like, given the fact that between these two values, that would be 600. This is slightly above 600, not up to 700. I would actually raise this a little bit higher and say maybe 650. So with that, the difference between 400 and 650 is 250. I think I'm going to actually have to stop here and give you guys a part 2. So please look forward to the second part of the answers. And I'm also going to go over the quiz and show you your quiz grade if you check your email. So do that too. I'll talk to you guys in a couple moments.